Alright, so this is problem 474D code forces. The problem is called flowers. You have 1.5 seconds per test. The memory limit is 256 megabytes. You have standard input output, and yeah, the problem is we saw the little game Marmot made for Mole's lunch. Now it's Marmot's dinner time, and as we all know, Marmot eats flowers. Every dinner he eats some red and some white flowers. Therefore, a dinner can be represented as a sequence of several flowers, some of them red, some of them white. But for a dinner to be tasty, there's a rule. Marmot wants to eat white flowers only in groups of size k. Now, Marmot wonders how many ways he can eat between A and B flowers. A number of ways could be very large, so we need to print it modulo 10 to the power of 9 plus 7. Contains several test cases. The first contains two integers, t and k, where t represents the number of test cases, and k is going to, obviously, as we know, represent the white flower grouping. The next 10 lines contain two integers, ai and bi, describing the ith test. Print t lines to the standard output. The ith line should contain the number of ways in which marmots can eat between ai and bi flowers at dinner modulo 10 to the power of 9 plus 7. So here are some examples. So for an input where we got 3 and 2, that means that there are going to be 3 test cases, and the marmot can only eat white flowers in groups of 2. So for when we have a length of 1, the marmot can only eat a red flower as is shown. For a length of 2, the marmot can eat 2 red flowers or 2 white flowers. For a length of 3, the marmot can eat 3 red flowers. The marmot can also eat a red flower and 2 white flowers, and the marmot can also eat 2 white flowers and then a red flower. For k equals to 2 and length is 4, which is the next one, marmot has actually a lot of options here. He can eat a consecutive white flowers or RWWR, or he can eat RRWW or WWRR or full R. So that's 5 that I just listed, and that's going to give us 5 as we can see in the output. So from 1 to 3, that's going to be R plus RR plus WW plus basically 1 plus 2 plus 3, which is 6. For 2 to 3, that's 2 plus 3 is 5. So 5, and for 4, that's 4. So how are we going to do this? So pause the video now and think it out yourself. And once you have an idea, well, you can come back and unpause. Alright, so what we want to do is we're going to want to start off, and we're going to use a DP algorithm here. So what we're going to do is first we're going to keep track. We want to find the maximum I value we're going to need, because there's no need to calculate any further than that. So we want to find the basically the maximum b value. So the way we can do that is pretty simple. We can just iterate through all the b's and just calculate the maximum, which is, in this case, it's 4. So then we want to create an array of size 4 plus, so wait, that's going to be, let's call it max of b. So max of b plus, and then we want to get the k value, which is going to be, just in case you guys forgot, the k value is the number of consecutive flowers. And then we're going to want to add 1. And I'll explain why we add this 1 in a second. So so for max b and k, what we're basically going to do is we're going to say that we know there is only one way to eat one flower, no matter what. There could be 2 ways, actually, so you have to check if k is equal to 1. So basically we want to say there's one way or two ways, depending on what the value of k is. We're going to assume for the time being that k is not equal to 1, and so this is going to be 1. And then what we're going to do is implement a DP algorithm. So for the time being, let's assume the sample input that we got. So just going back here, we have that there are the maximum b value is 4 and the t value is 2. So going here, we'll say there's going to be 2 plus 4 plus 1 is 7 values. So that's going to be 1, 2, 3, 4, 5, 6, 7. Now, what we're going to actually want to do is we're going to want to erase this and keep this as 0 and keep this as 1 or 2, whichever one it is. So in this test case, it's 1. Now this is 0 because we are going to be using a prefix sum later on, which will make, and keeping this as 0 will help with that. So when this is 1, the first thing we're going to do is we're going to say this right here, the value in here is going to be incremented by the value here. So that's basically we're going to increment this value by 1. That'll give us 1. And then we're going to, and that's because we can always just add a red. We can append a red to the end of anything from here. Any case that we can go up to this point, so basically any amount of times we go up to 1, so that would be like the number of cases where 1 works, is also equal to the number of, is also going to be equal to the number of cases where 2 of them work. It could be less. So basically, sorry if this is confusing, but what I'm trying to say is, if we have a sequence of letters, say R, W, W, R, and this has, and like so on and so forth, and this has a length of n, then we know that R, W, W, R, dot, 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 and then at the end we can put an R, is also going to be a case. So for each case in n, it corresponds to one case in n plus 1. And then on top of that, we have to consider adding the W's. So how are we going to do that, you say? Well, what we want to do is we want to also initialize the kth index to 1. And that's because there's one extra case there where we start off with a bunch of whites. So our k value is 2, so this is going to equal 2. Next thing we're going to want to do is we're going to want to take the n value, and again, so actually, we want this. We're going to want to take the n value and say we have a sequence here, sequence of size n, then sequence followed by whites, k times, this is going to have a length of n plus k, is also going to be a case. So we're also going to have another correspondence from n to n plus k. So what we're going to do is we're going to take this, we're going to say increment this by 1, and then increment n plus k by 1. So 1, increment 1 plus 1 by 1, so increment the second index by 1, and then increment the 1 plus 2 is third index by 1. Now, at the start, this one also had 1 because it's the starting k value, so this is going to be 2. Now, let's continue this case. We're going to move to here. So we have 2, so we're going to increment this value by 2, this is going to give us 3, and we're going to increment this value by 2, this is going to give us 2. Then we're going to increment this value by 3, this is going to give us 5. We're going to increment this value by 3, so it's going to give us 3. We're going to increment this value by 5, 8, and then this value by 5, 5, and finally we're done. We can stop here. And that's because this is the 4th index, there's no need to calculate further than that. So now you see, we've perfectly filled each and every index in the array. And so this is going to fill up n times. It's actually going to fill up, max of b plus 1 times. No, max of b times. And it's going to go from 1 to max of b inclusive. And the way I'm going to denote that is I'm going to denote with a dot here. So it's from 1 to max of b inclusive. And so then all we have to do now is go back to our test cases. Next thing we have to do is generate a prefix array. So you might be asking, what do you mean by prefix array? Basically, what I mean is the sum up to a certain point in the array. So the prefix array for this would be 0, 1, 3, 6, 11, 19, 24. Basically, if you take any index, say this index, the prefix array's value of that index is the sum of all the values from here. So now that we have this, we're pretty much done. Now all we have to do is go through each of our inputs. So our inputs are 1, 3, 2, 3, and 4, 4. So let's write that down. We've got 1, 3, 2, 3, and 4, 4. So what we want to do is we want to take the first input. This is going to be 1, 3, and we'll take the 1 minus 0, 0th index, and the 3, 3rd index, and we'll subtract this from this. Now what that'll give us is it'll give all of this, so all of the values up to this point, excluding all of the values up to that point, which if you'll notice is just that, which is what we wanted. So if we try it for another input, say 2, 3, then we would just want these values. We just want the second and third value. So what we would do is we would take this, and we would take this, and we would subtract 6 from 1. And that would give us 5. So here we would have 6, here we would have 5, here we would have 5. And this 6 comes from 6 minus 0, this 5 comes from 6 minus 1, and this 5 comes from 11 minus 5. And just to clear up any confusions, that was not meant to be there. So that's basically the logic here. And from here, we can pretty much just get started. So yeah, some things that we'll need, obviously we'll need a DP array. We're going to need a prefix array. And we're going to need our test cases array. And once we initialize this entire thing, it's O(n) time basically, so we can fit the test cases. It's O times O of t, the number of test cases. So that's basically what we'll do. And this test cases array just stores all the test cases, so it's more of an array of an array, and it's of size t2. Okay, let's get to work on coding this. So here I have an empty class, and what we're going to want to do is initialize the way we always do our main. And so we'll start by creating a buffered reader. Is a new buffered reader of new input stream reader of system.in, and then string tokenizer st is new string tokenizer of f.readline. So our first thing is going to be int t is integer.parseInt of st.nextToken, and our int is going to be k is integer.parseInt of st.nextToken, and then we're going to want to create our inputs array, and this is going to be an int array called inputs, and it's going to be it's an int array called inputs, and it's going to be a new int array of size t of 2. And yeah, so these are going to be our inputs, and now all we have to do is iterate t times, and we're going to say st is new string tokenizer of f dot read line. We'll keep track of an int max b is 0, and int this is going to be a is integer dot parse int of st dot next token. Int b is integer dot parse int of st dot next token. And so then we're going to say max b is math dot max of max b. And so we've got that. And then finally we just need to put these into our inputs array. So inputs of i is equal to new int array of a comma b. And I don't think we actually need that there. Nope, we do. Sorry. Just to be safe, I'm actually going to say of 0 is equal to a, and then inputs of I of 1 is equal to b. And so from here, what we can do is we've got our max b. Now we can start our two arrays, which is going to be dp array. So this is going to be a long array. Dp is a new long array of size. This is going to be max b plus k plus 1. So max b plus k plus 1. And then we're also going to have a prefix array, so pref. And I'm actually just going to call this pre. And this is going to be our prefix array. So now, some things we need to do. Step 1, dp of 0 is equal to 0. Dp of, pre of 0 is equal to 0. And then, so if k is equal to, what we want to do is we want to say dp of 1 is equal to 1 pre of, and then dp of k plus equals 1. And then we want to say a pre of 0, a pre of 1 is going to equal dp. And this is just setting up some different background things that we will need. Right, so now what we're going to need to do is, actually we don't need to do this, we're going to do this later. So we're going to iterate precisely max b times, except we're going to do a less than or equal to here and a 1. And so we're going to say that dp of I plus 1 plus equals dp of I, and then dp of I plus k plus equals dp of I, and then pre of I equals pre of I minus 1 plus dp of I. And that's our dp initialization. Alright, so just checking back into here, we can just confirm quickly that it works indeed. It appears to work quite well, and from what I can see, it should not error out. So we can go back here, and that's our prefix array, and we're done. So now we need to iterate for int array inp and inputs, int a is inp of 0, 0, int b is inp of 1, and then we're going to say, let's just subtract 1 from this. So we're going to say that we want to print pre of b, we want to print pre of b minus pre of a. And that should be it. So what we can do is now we can actually test it. So I'll go to the terminal, we can cd into source and Java compile that. And then we can Java it, cf. And so now, just copying the input, it says 655, which is exactly what we had. However, we have forgotten something, which is that we want to take it modulus. So there is a legitimate chance that we get an overflow here. So we're going to have to do a lot of modulus thinking. Basically, the answer could get too large, but there's a possibility it could get too large even for a long. So we need to take it modulus 10 to the power of 9 each time we're doing a pre. Now, that 1 to the power 10 to the, yeah. So each time we're doing a pre, we need to do that, but then what happens if the DP overflows? We don't know. So for now, what I'm going to do is I'm going to actually say, just take this modulo 1007, and this should be enough. If it's not enough, we can just edit the pre, and if that's still not enough, then we can edit the DP array to have that too. But this definitely should be enough. So copying the input, 655, it still seems to work, so let's go here, and I can just close this out. And we can choose our file. So I'm going to just quickly choose it now. This is 474. And yeah, so let's submit it and we'll see how it goes. So it's in the queue and it's got a wrong answer on test 5. So it's probably just that it's way too big. So the check log says that these two differ. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. There appears to be a problem. Oh no. Let's check, is everything else wrong? And we've got overflows here. We've got overflows, so there's definitely a problem. Most likely this problem is going to happen in our DP array, so we've got to fix that. So in our DP array, we've got to take moduluses. That's going to make things a little bit harder. But it shouldn't, so I'm just going to do this. Now this shouldn't affect anything, really, because we can take modulus of 1000007 wherever we really want, but it might affect the runtime, which is scaring me a little bit. And also, the fact that we had negative overflows does mean that we're going to have to create a capacity check. And what I mean by that is I'm going to say int ants is this long, sorry. And we're going to say if ants is less than 0, ants plus equals that, and we want to print out ants. This should work, I believe. If it doesn't, we'll have to see why it's not working. Okay, so it is working there, and I'm just going to quickly choose the file. Oh, let me switch. So I'm going to quickly choose the file here and submit, and we'll see how it goes this time. So it passed test case 5, and great, it's done. So I expected that to happen, and the reason I did is because I knew that the DP array would overflow. And what happened probably in that first test case is that it overflowed past the negatives. So what I mean by that is in that test case where it was nowhere near close, it would have gone past the long limit, and then that means it would have overflowed into negatives. So if we have long max, and then we've got some integers long min, we would have had our answer is here. So we would have gone all the way up. This would have taken us down back to here, and we would have gone all the way back up here, which is quite surprising if you think about it. That's a lot of integers. That means the answer is really, really, really huge. So, and it might have even gone continuously cycling through, and then finally hit its answer. And we really don't know what it was, but by taking the modulus each time, it fixed the problem. So yeah, that was the Codeforces problem 474D flowers. And yeah, I did want to say that today is New Year's where I am from, so I really do hope that you all have a great, great, great New Year's, and that the 2021 is going to be slightly better than 2020 was for all of us. And yeah, if you guys did enjoy, please do not forget to like and subscribe and share this video with people you know, and I will see you guys in another video.